Good evening, everyone, and welcome to OTF Connect, Beyond Solving Word Problems, Establishing and Supporting a Problem-Solving Culture in Your Math Classroom. Mary Kay Goindy is our presenter this evening. Mary Kay is a very experienced, educator. I'm sure she will tell you her variety of experiences which bring her to where she is right now, but I always find that really fascinating, the variety of experiences that she's had, and this proves to be a great session. Welcome to all of you as well. We have many returning people now that we're into the middle of December. A lot of you have found us and have been attending webinars in the past, and we're really glad to see you back. And I know that you're sharing this program with your colleagues, so we thank you for that as well. And a warm welcome to those of you who are new. My name is Susan Watt, and I'm the moderator for tonight, so I'll sort of be in the background as soon as I turn off my mic and helping you with any issues. I see Monica's got a question there, so I'll be answering that shortly. So I'm going to turn off my mic now, turn things over to Mary Kay. Welcome.
Thanks, Susan, and thanks everybody for coming. Thumbs up, so use that first toolbar tool if you can hear me just fine. I tested my mic before, but I get nervous starting and just want to make sure we're good. Looks like a lot of green checks and a lot of thumbs up, so I'm going to assume that's great. I want to start by inviting you, if you're on Twitter, you might want to type your Twitter handle in the chat. It's a really great way to connect to other people. So you might pick up somebody else's Twitter handle in the chat and maybe make a connection that lasts for, a week, a month, years, and have a great teaching partner, even if you are at opposite ends of the province. And my Twitter handle's on the slide there. It's at @mkgoindy, and it's also beside my name in the list of participants. So welcome, everybody. I'm not sure if I'm the only one. I realized today that I'm actually teaching until December 23rd, which is like a little scary since I've got 15 people coming to my house to stay as of December 24th. So I'm kind of just before that holiday panic mode, and hope that you're not in that panic state yet. Maybe we could use the polling tool now, and I would like to know, did you teach math today? So green check if yes, I taught math today, and X if nope, you didn't teach math. Kind of gives me an idea that we have a lot of active classroom people today, I'm assuming. As the poll's coming up. Right now I'm seeing 23 yeses and 7 nos, so lots of classroom teachers. Maybe if you taught in JK to grade 3, could you give me a green check? And if you taught grade 4 or higher, pick the red X or the no button. So grade 4 and higher is no. And that'll just give me an idea of how to tailor some of the optional parts of today's session to make sure that I'm talking about what's most helpful to you. I see that D is having problems with the audio. So I'm going to clear the polling tool. Green check if the audio's fine for you, and red X if it's not, because we might as well solve that. I'm only getting green checks, D, so I'm afraid it's you. Going back, one more question. Did you teach math through a 3-part lesson today? Yes, green check yes, red X no. Oh, interesting. Sorry, you don't see the numbers. I've got 2 yeses for 3-part lesson, 19, 20, 22 X's for not a 3-part lesson. So I'm going to reword that question. I told you last question, I lied. Did you teach math through problem solving today? Green check yes, red X no. I've got more yeses than nos by quite a bit, so 2 to 1. All right, in the blurb I said you would do some math. So here is some math for you to start with. source is from NCTM on Facebook. Here's a problem for you to wrestle. Feel free to type the answer in the chat if you want, or just make sense of it for yourself. Think about how you would solve this problem. Oh, sorry, Kathleen. I hope it's not poor Grandma Lucia here who's giving you a headache. I did warn you that there would be math, but there's not much. Well, it's all math, but not a lot that you have to figure out like this. She's 59. She's not 59. I agree with you, Mark. I believe she's 56. And when I do math like this, I would never really talk to the students about the answer. I would talk to the students, and one of the questions I would ask students when I propose this problem to them is I would say, can Lucia have one son? And why? And then I would always have students talk to one another about this. So I'm asking you, can Lucia have only one son? And why do you think no? Awesome. Kathy used the notion that it says sons, so the plural nature of the word says no, there has to be more than one. She's got, each son has as many sons as brothers. So unless there were no other sons, there could be no brothers. I've had this problem. Oh yeah, and then S, right, sorry, I don't know first name there, says the age has to be between 50 and 70, and it's a product of sons and grandsons. How did you get 56? Somebody told me 56. Want to grab the mic? Or do you just want to type? So I'll talk just because it's probably faster than somebody typing, but if the answer pops up, I'll stop talking. Each of her sons has as many sons as brothers. Okay? So, if she has 6 sons, how many sons does each son have? I guess is how we word that through. Right, 5, because she has one less, because you're not your own brother. So if she has 5 sons, 6 sons is what I said, she'd have 5 brothers. How many sons and grandsons would that be? That would end up being 30. So then just working it up, we get 8 sons each of whom has 7, I guess Lucia's grandsons, which would total up to 56. 64 wouldn't work. How could we get to 64? I think 64 would be if each of her sons had the same number, no, had more sons, one more son than brothers, because you can't be your own brother. So that is the thing here. So I've given this problem to a grade 3 class because it's really the multiplication of 2 one-digit numbers. And they solved it almost like a tree diagram. And it took the ones who persevered close to an hour, but they solved it. I also gave this problem to a grade 7 class, and they solved it algebraically. And just kept, actually they did guess and check. They figured out what the expression would be, and then did guess and check with the numbers until they ended up in the right age range. So this is problem solving. The strategy to solve the problem is not obvious, and there was a little bit of work needed to be done to get the numbers. The numbers weren't just given blatantly to you, and you didn't have to just plug them in. There's a lot of reasoning that is included in solving a problem like this. Anybody want to say anything? And we can talk about 64 or 56 later, but for the sake of moving on, does it have to be a word game too? No, absolutely not. And this is actually a little bit more riddly than I would ever give students in my class. This was just straight from NCTM on Facebook, so I thought I would pull it in because that is a source of problems, and sometimes you can choose to do it and sometimes not. I agree, this is a lot of reasoning. It's a puzzle, more than just a lesson that comes along to build a skill out of the curriculum. And I agree, the words can totally spin you around so fast that you don't know which way is up. Anybody have a comment on this slide? Education is not the learning of facts, but the training of the mind to think. Check mark if you agree, red X if you disagree. And I'm only seeing green check marks everywhere. Green check marks on the slide and in the polling tool. So if you believe this, how does it impact your work with students? What kinds of things happen in your classroom that would tell a visitor to your room, this is what you believe? Monica, do you want to talk about that a little bit? A balance. A balance between what? See, I think some of you could be giving this session instead of me. We'll go back to the problem at the end, Lois. I think it's 56 still, but we can get back and talk about that later. And all of these I agree with what you're saying here, but how will that show up in your classroom? Students working together, problem solve. Okay. All asking rich questions. Absolutely. Number talks. Questions from the kids. Absolutely. These would definitely be clues that you believe in this. And that's a good thing that you do believe in this, because in our curriculum on page 11, we are instructed, and it says that problem solving is to form the basis of effective mathematics programs. And it should be the mainstay of math instruction. So it isn't what we do on Fridays, and we don't have a problem of the week. When we teach math, we should be teaching through problem solving. It's what our curriculum calls on us to do. And the line I kind of cheekily say sometimes is, we're not self-employed. We don't get to decide exactly what we do. We get choices and professional choice within the range, but we do have to follow the curriculum, and this is what our curriculum says. The problem solving is really key to me, and I've done a lot of reading on just how learning happens in general, in math and in other subjects too. And there's the National Research Council put out a study that says that cognitive dissonance, so that feeling of, I don't know what's going on, and this whole notion of a mental struggle, they're required for you to learn something. And if you don't have that panic or that, you're not learning it. You might just be practicing it. You might be reinforcing an idea, both of which are great things to have happen, but you're not actually learning. So when your brain is changing and you're making a new pathway, synapses firing, all that brain chemistry and brain science is happening, that cognitive dissonance will really, well, it's required for that learning to happen. I'm peeking into the chat here. Kathleen said it's tough developmentally for students. I don't know. I'd love you to say more about that. And Kathy G said something. Oh yeah, teacher as learner? Absolutely. Really, really key. I love the last line too, Kathy. Math should be filled with wonder, surprise, cool stuff, patterns. Absolutely. Feel free to grab the mic too. If you're happy to keep typing and just have conversations, that's good. I'm going to miss a lot of it, and I will come back and read the chat later. So feel free to grab the mic and add your voice. Your fingers may get tired. I love this next slide. I'll give you just a second to read it. I actually used to believe that my job was to make sure that students would respond in the same way and that they wouldn't struggle at all. I believe that's what I was supposed to do. So I thought an effective math lesson would begin with me demonstrating the skill, and maybe I'd make up a little mnemonic or something to help students remember the steps. So I think it's like one of them was Dracula's, what was it? Divide, multiply, subtract, bring down. Dracula's mother sucks blood, or something like that was the mnemonic that kids used to tell me that they used to help them remember the steps in long division. And so we'd make little posters and the kids would know exactly what steps to do. I would do a sample problem on the board, and then I would make sure that they were able to follow my example, and then I gave them other questions or just calculations for them to imitate my strategy. And then when I was fairly confident that they could actually do the calculation, that's when I gave them the problem and expected them to apply that calculation skill to get the problem. Thumbs up or green check. Is that how you were taught math, or is that how you first believed math should be taught? You teach the skill, and when they get the skill, then you introduce the problem. Okay, good. I'm not alone. So I'm either, for years and years and years, Stephanie, you're right. That's how math was taught. In fact, it's not that way. All the research is now saying, and we have more information now because we can see what happens inside a brain without actually cutting the head open. So with those sensors on the brain, we see which part fires and we see new connections made. Instead, I now see my job as the hurdle setter upper. So I believe my job is to put hurdles before the students, not so high that they can't get over them. So I do consider zone of proximal development, and I try to make sure that the hurdle is a reasonable jump for the student, but I make it high enough that they can't just walk over it. If the student can just step over the hurdle or immediately get to a right answer, then I haven't done my job in providing them with cognitive dissonance. And if I haven't provided them with cognitive dissonance, then they're not learning. I often kind of feel badly about all the kids in my classes that never learned anything. They already knew. Math was so easy for them. They flew through every calculation. They did everything, and I think now, oh, I missed my chance to really help them learn. They felt successful. They were successful in what I was providing them with, but I missed that chance to get them really learning. So I now know better, so I try to do better. And that's kind of what I wanted to share with you tonight. Is this familiar to you, this framework of a three-part lesson? Maybe mine's on action and consolidation. Maybe these are the words that you use, or maybe in your board you use other labels. But for a three-part lesson, these is kind of how I structure my math lessons now, almost every single day, with a very few exceptions. I've done a webinar on teaching through a three-part lesson before. We were kind of wondering, Siri and I were talking about, is it worth repeating? So if you are new to teaching through three-part lessons, you have options. You could go back and find the recording, or maybe you'd like me to repeat it. So if you are at all interested in having this repeated, you could put that in your feedback later, or maybe just give a green check now. And if there are enough green checks, then I would know that in the winter session, we could rerun this. I'm seeing the green checks come up, so I'll put that forward. Absolutely, I will explain the 1, 3, 6. These are the time ratios. So for, let's say, a regular 50-minute class, which is what my grade 6 classes were last year, 1 part would be the minds on, 3 parts would be the action, and 6 would be for what I would say for the consolidation of the lesson. So that meant 5 minutes for the minds on, 15 minutes for the action, where students would solve or attempt to solve the problem, and then 6 minutes for the consolidation. Now in a grade 1 class, I would never do a 50-minute problem-solving lesson. So when I taught K in grade 1, the minds on would be 1 minute, the action would be 3 minutes, and the consolidation would be 6 minutes. And then the rest of the time, we would practice, go to more independent practice or fluency or do something else related, but the actual problem-solving part of the time. So what's funny about the ratio? 1 part minds on, 3 parts action, 6 parts consolidation. Oh yes, what did I say for 6? 6 should be 30 minutes, you're right. So more than half of my class is the consolidation. Sorry, you're right. That's what, I just misspoke. Absolutely. No, Nancy, I don't think more time should be spent on the action. In my class, not all students get the answer actually completed. And we knew that was okay for the learning, because we were learning a new skill. It wasn't about necessarily getting to the right answer. The teaching absolutely comes in the consolidation, and I broke my consolidation even further. So I taught what I now call 5-part lessons. So after students solved the problem, or at least attempted to solve the problem, they would then share their work and compare it with another group of students. So students always worked in pairs in my room. As soon as action ended, they would go to another partner, another pair of students, and they'd share and compare their work. They'd talk about what they did, and they looked for what was the same and what was different. Then I would go, and the highlighting is my time. So of the 30-minute consolidation, I got the 10 minutes to highlight the teaching. This is where I would build the learning goal. This is where I might construct an anchor chart, work on success criteria, really drive the meat of my lesson home at that point. And then independent practice was the last 10 minutes for students to either solve a similar problem or maybe solve just isolated calculation questions that were related to the problem that we asked. So I saw some question. Rhonda, I used to say that you could go over 2 classes, but all the research says it has to happen the next day. Because of the nature of the student brain, and because of how their life changes so quickly, if they really want to consolidate it, it should happen that day. And so I have changed how I do my math to make sure it does happen on the same day. I'm just trying to scroll up because I saw some other questions. What happens in the action? The action would be where I give a problem. Am I okay, Susan, to keep going? Is it me that's staticky and cutting out?
No, it's not, Mary Kay, but I can see that there's a couple of people that are having issues.
Okay. So. Okay. Sorry, going back then, the action is when students just work with partners, large chart paper, markers, all the manipulatives are out, they're building their towers, they're solving the problems, they're taking photos, they're trying to make sense of the problem I have posed to them, and they're trying to record their work. That's what action is. As I said, there's more information where we spend like 90 minutes just deconstructing the 3-part lesson. Okay. But if the green checks were true, I will talk about possibly repeating that lesson so you can join in the conversation more than just listening to the recording. Any questions right now? Hands-on is definitely during the action. And so for some who are worried that 60 minutes isn't enough for a 3-part lesson, I'm thinking maybe you're taking too much of a learning goal. Your bite for that lesson is too big. And if you really wean down your learning goal, possibly it will fit in a 50-minute class. A Minds On, well, here, I'll give you a Minds On right now. So here's a grade 5 classroom. I kind of put what I would do to build a problem. This is a word problem situation. So when I know I am going to be teaching area, what I do is the week before, I do some art that's about mosaics. So maybe I would have them create a mosaic using square tiles that shows a round image or creates some kind of round sense. Or maybe my learning goal in art would have been warm colors. Can you create a mosaic of warm colors? And I would make sure that they have square tiles for their mosaic, and just so that they're kind of working on this whole notion of covering a space with smaller squares. So that's what I would do in art the week before I start to teach area. Sorry, I'm clicking the wrong button. Then I go back to the curriculum and I find all of, now these are specific expectations from the grade 5. One is number sense. I remind myself that in grade 5 they multiply 2-digit numbers by 2-digit numbers. So all my area calculations, this is a great chance for me to practice that multiplication, so I'm going to make sure of that. Then in the measurement there are those 4 specific expectations. I'm reminding myself I've got regular and irregular polygons, so I can work in that. 2-dimensional shapes using a variety of tools, so I'm going to be hands-on, but I'm also going to be using a ruler and pencil and paper. I'm planning all of this out, so I make sure I'm hitting the what and the how and the when and the whys that are in all of my specific expectations. And then I go ahead and I find 2 expectations in patterning. all of these expectations can become my learning goals for any one of my lesson that is coming up. So this would be the first task I give to my students in grade 5 that addresses the concept of area. They've done the art the week before, and I would give them a piece of paper. And I would just ask them, how many 1 centimeter by 1 centimeter tiles would be needed to cover this square? For the sake of the assignment, I gave them 16 by 16 square. But notice I don't actually tell them the size of the paper. I'm focusing here on measurement. And what kills me is when we teach measurement, students should be measuring all the time, every day. With the ruler, they measure. If you want them to find area of rectangles, there are so many rectangles in your classroom. Don't make them do the assignment out of a textbook. Make them find the rectangle where they actually have to measure the dimensions themselves. Lots of students struggle on the whole notion of area being 2 dimensions because it doesn't, like they have to put the ruler one way and then the other way. That reinforces that 2-dimensionality of a rectangle. But reading it off a piece of paper, that's very flat. So I don't tell them the dimensions. And then I watch and I try and figure out what's going to happen. So you are now the teacher. You've given them this problem. The square, the larger blue square there, is 16 centimeters by 16 centimeters. What do you think you're going to see students do? Grade 5 teacher, first area question. You have not taught them area, although they have been working with area since they covered other things with recipe cards and everything like that in grade 1. Absolutely, Rhonda. Oh, they're going to cut squares for sure. Lay the tiles on the squares. Yes, tiles would be, because that would be the whole 15 minutes. Remember, they're having 15 minutes in my class to do this. And where would the lines be, Stephanie? And Rhonda H., what would they do after they laid those tiles on top of the square? Oh, I like Charlotte's thinking. They might put the small tiles along the 2 sides and then do some multiplying. They might cover the whole thing and count every tile. Absolutely. Absolutely. So, I skipped ahead a little bit, but then I'm coming back to this. I would, at this point, after the action, I would stop. And I would have them share with another partner what they were doing. All of the strategies that you talked about, I expect I would have seen in my classroom, in my grade 5 classroom. And so some students would have been covering the whole larger square. Others would have had made sense that if they just cover both of the dimensions and then do some multiplying, they're building an array. Others would have used a ruler and drawn centimeter by centimeter. Some would have realized they're going to have 16 columns with 16 rows, and they're going to start making sense of that array. Absolutely. I maybe wouldn't talk about that on the first day. In my highlighting on the first day, when I get to go teachery, I might talk about the 2-dimensionality of the rectangle. Say that I saw you drawing lines that go vertically, and I also saw you drawing lines going horizontally. And I might have also consolidated the fact that it's really important to measure accurately, because even in grade 5, using a ruler is a challenge for a lot of these students. So I might not even have addressed the answer, and I definitely wouldn't have brought up any formulas for areas on day 1. So now we're going into day 2 on the same problem, and my minds on would have been, and minds on for me always happened in partners, and it always had to have talking, and both partners must talk. So I would say, turn to your elbow partner and remind each other about what happened in math class yesterday. And I would just give them 2 minutes to kind of talk about it, and I'd walk around and I'd listen for words that I wanted to write on the board, and I would just write some keywords on the board or on the chart paper, and then I would stop these conversations, and then I would ask if anybody wanted to make a comment on any of the words I'd written down. We might be clarifying some misconceptions or some definitions and terminology, and I'd ask for if anybody had questions. Then I would have partnered the students intentionally. And even though this is not a word problem, this next lesson is actually teaching through problem solving. And sorry, I just saw in the chat, what happens to the student who does not come up with a strategy? It's 15 minutes of their life that they didn't know what to do. That's a good 15 minutes for them to have just realized, I might as well have tried something. And none of this is for marks. This is just to push them forward to learning. So if they sit there for 15 minutes, they're talking with a partner, they maybe just eliminated all the strategies that wouldn't work, and that is actually good learning too, is knowing what wouldn't work. And you're right, Stephanie, that is the cognitive dissonance. Sorry, I've got two Stephanies, so I feel like I'm talking to the same person. So here's what I might give to one student. Students that I saw cover the whole tile with small squares, or cover it and then count rows and then add them all up. I would present this sheet to the pair, and I say, this is what 3 groups did to answer yesterday's problem. Can you tell me what is the same and what is different about these 3 calculation strategies? Now, for another group of students in the class, I would give them this. I saw some students write these calculations on their page yesterday. Can you tell me what's the same and what's different about these calculation strategies? And so this is now the problem that students are wrestling with on the second day. They're trying to, okay, you know, these groups in this just added. They may be counted, and some maybe didn't even see the groups of 16. They may be counted by ones and just going forward, and that would take a long time. So I would then, in my highlighting, I would give these strategies names. So the long column of 16s, I call that just repeated addition. And I would say when you're trying to find how many square tiles will cover another square, this is a strategy. You count how many rows you can fit and how many columns, and you can add them up, and it will absolutely work. Then the next 2 strategies I call repeated addition with friendly grouping. Now the group that solves the problem with the first calculation, I try and move them to the second calculation because that's reasonable. To move a group who did repeated addition of 16s, because in grade 3, they've practiced multiplying by 10. So they should know that 10 groups of 16 is 160. And if they didn't remember it, I don't think it's going to be a big, big push to get most students to see that. And then they only have to do the remaining 6 groups of 16. But doubling is a great mental strategy, and so some will pull in that friendly group of 10 and then add the doubles. So my 2 strategies here are just repeated addition and then repeated addition with friendly grouping. So this is a good jumping point. I take the first column to the second column. The group that did this repeated addition with friendly grouping, I move them to this matrix, and this is called partial product. This is why you work on place value. This is the whole point of knowing place value. So when you break a number into expanded form, you can use your math facts to do this multiplication quite easily. And then we have the traditional algorithm. And so that's the second day, maybe even the third day. On the third day, I'd probably have them practice, where I would maybe just give them multiplication questions and see how they do. Are they still just using repeated addition? Are they using one of these other strategies to kind of make their work more efficient? But I will argue that going to the algorithm is not always, the standard algorithm, the calculation on the right, should not always be the goal, because it's not efficient for some students if they always get the wrong answer or if they always start and stop and start and stop. And my rule in my class was, you see that small 3 that I have written up there, if a student couldn't explain to me what that 3 represented, I wouldn't let them use this strategy, because they don't see that as 30. They don't see that as the 6 times 6 is 36. They don't see that as the group of 30 from that multiplication question per se. So I'm very kind of sticky about that. Any questions that I've missed? Anybody want to put a hand up and type something? Anybody want to grab the mic? So this is kind of a word problem, and this is how I would attack it. Maybe I've just gone to calculations, and then this might be my next word problem. Going back to that expectation of there's a connection between the length and the width, and the same area could have different perimeters, and going that way. So these would be word problems that are fairly prevalent in my class. It's not the wordiness of the problem like Grandma Lucia. It's really right down to the math, and it's anchored in their work in art the week before, remember. So I'm not spending a whole lot of time explaining the context of a problem. I'm using the same problem, the same experience, the same context to really help them focus on the math and not constantly having them make sense of the new situation. And then I would leave that. So that would be my little bit of work on area. And I would leave it, and I would maybe go to do data management or something else, and then I would come back to area. And the reason I do that is if I do 3 weeks on area of a rectangle, how much is that cognitive dissonance after the first week? It's gone for most kids. They know what they're supposed to try to do. Even if they're not getting the right answers all the time, they know that it's going to be an area of the rectangle problem or something very similar. So I have gone away from teaching through units. I go through little 3 or 4 lesson cycles, and then I go to something else, and then I'll come back. So maybe 2 weeks from now, I'm going to come back to area. But rather than talking about square tiles, I might give them the dimensions of a wall and tell them what area a can of paint would cover, and do I have enough paint? So I've gone away from the little square unit that I'm giving them, and I'm having, it's a more abstract, and will they visualize those little squares, or will they just be able to use the 2 dimensions and kind of mentally build that array and get to the area calculation? Absolutely, I spiral through the curriculum, Erin. I go through and through and through, because remember that slide I showed before, I hit, I think it was 4 measurement, 2 patterning, and 1 number sense with just that one problem. So I'm going to go back and leave that. One, because sometime, if I don't get something on Monday and Tuesday, something has to happen. I'm not likely to just understand it automatically on Wednesday. But maybe in a week from now, my brain will have wrestled with it even when I wasn't focusing on it, and maybe it's going to make more sense. So I want to give that time in between for kids to make sense of it. And maybe something's just going to click. We've all learned something that we tried, and then something happened and it clicked. So I try and leave space for that kind of aha moment. Little bit of a mid-webinar chuckle. I always, Stephanie R., I always am addressing multiple strands. I can't think of very many times that it's only a one strand unless I'm direct teaching how to use a protractor, and that would only be geometry. But I can't think of much else that wouldn't be multi-stranded. I heard a ding. Did somebody have a question? Or was it just an accidental? Lois. I'm not sure if you're going to grab the mic and talk or type, or should I be scrolling to find something? I'll get to assess. Absolutely. I'm not sure if Lois is typing. I don't see her typing. I just see a question. Oh, there I see typing. It is funny, and here's something else I found on the internet. I guess they're not really cantaloupes. They're watermelons, but and the point of this is not all word problems are created equally. Sorry, Lois, I was wondering about going back and the difference between doing a lesson one day and independent practice the next. The research says that you should have some independent practice every day, right after consolidation, and as close as it happens to the action and the time when the teacher highlighted the learning goal, the better. That doesn't mean that I wouldn't just do practice the next day. So maybe I'm going to just give students one calculation on one day, and if everybody got it, maybe I don't need more independent practice than that. If half the class got it, maybe I have half the class practicing just the calculation, and I have the rest of the class solving a similar related problem. So everything I've read says one day is best, and that's what I am trying to stick for. And I know that somebody asked earlier for the research, and I will try and track that down tonight and tweet it out, and I could definitely email. Oh, and Nancy, absolutely. Kids must do independent work. This is not always partner work. The learning can happen together, but students must be responsible for working independently in math. That's what we have to assess for the report card. So there have to be times where they, one, practice just working independently, and two, actually work independently so that we can get that formal assessment data on them. Okay, so with respect to solving word problems, initially students rely on intuition. This is right out of the Guide to Effective Instruction. If you haven't read this book, it's a short booklet. It's about problem solving and communication, specifically put out by the ministry quite a while ago now, but it's still a good read. Until our curriculum changes, it's still relevant. And so when we give students word problems to solve, they're going to attack them with their intuition. So we have to make sure that the problem is familiar to them. And so sometimes we give them problems that they don't even understand. And I'm thinking about a situation, it was an EQAO situation when I taught in Drayton, a small town in rural Ontario. And one of the problems was about an alley. And in Drayton, there is no alley. It was about a rectangular alley, and they actually had to calculate the area of it, and the kids didn't know what an alley was. So I would never use that problem to help my students learn about area in Drayton. Just like probably in downtown Toronto, your students might not do so well on a question about a furrow. But those kids in Drayton would have absolutely nailed that question on the furrow because I knew they knew what area it was. Their problem was just on what the alley was. So especially when the concept is new to students or you're introducing something new, it's important that the context of the problem is familiar to the students so that their intuition kicks in and it's helpful to them. In that art problem, the students had that experience, that recent experience, and then their intuition helped them tackle the problem. They didn't need me to tell them about area first. They very quickly began to understand what area was, and once they saw their friends' work, they were all on board and they knew what area was. The fact that they'd done it before in other grades helps too, but we very quickly generated the expression area equals base times height, as long as base and height are perpendicular to one another. They made sense of that. So a lot of times people ask me about textbooks when I'm teaching through problem solving, and I am not at all opposed to textbooks. Here's the problem. I have a couple of problems. The format of a textbook, for sure the old ones, used to teach the calculation skill at the top of the page, provide some samples, give students some calculation questions, and then at the end have them apply it. So that's not really how we know students learn best. It's removing that cognitive dissonance. I know for a fact, I created a page like this for students. It was on addition. And in the word problems at the bottom, I just typed in numbers, and they weren't about addition. Students didn't even read the words. They just found the numbers and added them together. And that's the problem with word problems in a textbook. If it's that style of textbook, there's no problem solving involved. It's just practice at that point, which again, might not be bad, but if your intention is to teach through problem solving, then that has not been achieved. The other thing is textbooks are in longer units. So again, if you're working in the chapter called Area of Rectangles and you've been in that chapter for a few days, the students know what they're going to be doing on Wednesday. And if they're still in the same chapter, they know. They don't have that cognitive dissonance about being able to pull from their tools, what do I need to solve here and what calculation strategy might be appropriate. And that's what happens, right? We have lots of times where we know people that are really good at math if they know what math it is they're supposed to do, but they can't recognize now would be a good time to calculate the percent. They just don't see the connection between the calculation that they're really good at and when it's appropriate to do it in the real world. My other part of the textbook is just going back to that whole context. Some textbooks, depending on the community, they're not relevant. The names are distracting and the situations described are not at all familiar. And actually, fourth problem, textbooks aren't written just for the Ontario curriculum. You can do a whole lot of teaching from a textbook that's not in our curriculum at all. And you can teach the whole textbook and still leave some ideas that are in our curriculum out of your program. So using a textbook, absolutely. Great problems in there, especially some of the new ones. I mean, written by Marion Small and Kathy Fosno. They write these problems in the book. They're good problems. I just sometimes think that when they're packaged as the textbook, you kind of remove some of that problem solving and cognitive dissonance from them. Michelle's saying here about the limited application and thinking in a textbook. Absolutely, especially when it comes at the end of the unit where you already know what skill is being addressed. Problem two with textbooks or word problems in general is that they tend to go on paper. So when you are having students solve a word problem, the most common thing is for students to answer on paper. And I'm not sure that writing on paper is the best way for students to learn the math. It's great for practicing, and I really do distinguish between the two. When students are learning, I don't think they should be working on paper. Definitely not their own piece of paper. Maybe a group sheet, but not specifically on their own paper. And I believe that because this is what I believe. And this is why I don't think as teachers we need to tell them everything up front. And this is why my math classes are not quiet. And that's not the goal. I never want them to be really quiet unless it's, you know, independent practice, and then I don't care if it's noisy as long as it's respectfully noisy and it's as quiet as people need it to be. It's also why in my Mind's On, the rule is you must talk. You can't sit there and be passive. You have to say something, even if you just paraphrase what another group has done. And the first step of my consolidation is to have students share and compare their work with each other. So this is a monograph that came out a few years ago. It's called Grand Conversations in the Primary Classroom. It's specific, you'll see in the top title, about students talking about text in a language program. But this became an anchor chart in my classroom, and we used it all the time in math. Because I needed for them to be learning through problem solving, it would mean that they would have as many questions, probably more questions than answers, and so they had to talk a lot to sort out the problems that they had and to start finding the answers. There were always disagreements, but we just made sure that they were constructive disagreements. And so we use this language all the time. And I think it's a good anchor chart for every classroom, regardless of subject. It just really helps students talk to each other and keeps their conversations focused on the learning, not on judgments and everything else. And I use a lot of these apps. So I saw a lot of people use Whiteboard Apps and take pictures of it. I was always lucky to have enough iPads. So these are 3 interactive Whiteboard apps. Maybe you've used them. They always helped me because you could take a photo of the work, or the students could write right on the whiteboard, or they could annotate on the photo, and at the same time they could actually be talking. And it would be synchronous. The recording of their voice would be synchronous to what they were doing on the whiteboard, and it created a great archive of the learning that was happening in the problem solving. So, going on, word problems are great, but there are a lot of other ways that we can teach through problem solving without necessarily having a word problem per se. This is Scratch, and this is one of my favorites. Funny, it's the week of coding. Hour of Code week is this week, and Computer Science week in the province of Ontario. Thumbs up or green check mark if you've had students on Scratch before. Seeing 5 yeses, 2 no's right now. So I have had everybody from grade 2 and up successfully using Scratch. And for those that don't know, Scratch is a program that has been created by MIT, and it is what started as somebody's project, but they now still maintain the site. And it's coding, and this is called block programming. And I had students, well, here's the new problem. Can you create a coin flipping app that will simulate the flipping of a coin any number of times and calculate percentage of flips that lands head tails? So this was actually what my grade 6s did last year, and this was the code that one of them created. The cool thing is this little cat here, he's a sprite. Grade 2s last year were just programming this cat to draw a square on their screen. And then you can make it as complex as you want. These grade 6s were exploring the difference between experimental and theoretical probability. So the coding itself is problem solving, because you're sitting outside your computer and you're trying to tell your computer or a little cartoon character on your computer to do something very specific. Then, if you see the content or the actual subject of the code that was being written, it's also math-based. I didn't tell the students anything about percentage, and we didn't talk about probability yet when they did this. But this was then the event that when I consolidated, they had a sense of this experimental versus theoretical probability without having to flip a coin 1,000 times or 10,000 times. They actually do love Scratch. If you go on code.org this week, and actually from now for the rest of the year, that's a site for the Hour of Code. They have great tutorials. So if you are thinking, oh, this is too much for me, it's not. If you can get your students online and go to code.org, I think you'll find a tutorial that everybody will be successful, and there'll be just a great buzz in the room. And again, it's the buzz, and then somebody figures something out, and that spreads like wildfire across the room. And that's problem solving, and that's effective communication, and it's just all kinds of awesome. Okay. You don't need an iPad for this, but you do need access to the internet. So coding is another way. It's not a word problem, but if you teach through a program like this and provide a challenge such as this, that is teaching through problem solving. They need to pull knowledge from their understanding of anything, any content area, and put it in. You can actually code the little cat to say things too. So sometimes if a student learned a new definition or a new vocabulary, I would just have them code Scratch or this cat to make a little script and do a little play that proved to me they understood new vocabulary. It was engaging and problem solving just by needing to write the code. Here's another challenge that I gave students. So not just building in the virtual and coding. This was a huge hit last year where the students had to build a marble run. And the geometry expectation is that they need to recognize and construct these angles. When I gave them this challenge, I didn't pre-teach it, these angles names. So as soon as they got this challenge, they went online, they made sure they knew what these angles were, they got protractors, they started to build their run, then they started to create a video and use all the language because they had to point out where the examples of these angles were. Communication, teamwork, problem solving, construction, address specific curriculum expectations, and it was fun. And that's big. To have kids being excited to come into math class, unfortunately, is still a hurdle. Lots of kids still have math phobia. So when you've got kids kind of clamoring at the door to get in and rushing in from recess because they're expecting something cool like this to happen in math class, that's a big win. So I used white glue, and actually a lot of kids just with these craft sticks that we use, we just made indentations in the cardboard. We have make-dos, which are cardboard saws, so we actually just made indentations in the cardboard and stuck these in. Lots of tape. I mean, one of them was my huge library wall was covered with one. I think they had, I think we did it right in January last year. So they had like 20 wrapping paper tubes all hooked up and taped on the wall using painter's tape and all sorts of different contraptions. So some were as small as in the lid of a shoebox, and others took up like huge wall spaces in my room and around the rest of the school. Great challenge, great math, great measuring, great geometry, so much fun. Oh, I see pegboard, screws and elastics. Excellent. And this is the great thing. Nancy's talking about it being successful with her kindergartens. My grade 6s love this. For class time, this was a 2 period, so 100 minutes of class time it took. Flexible groupings for something like this, I let them choose who they worked with. Absolutely. I normally don't do that. But because of the building nature, they all just paired off. One of my rules is once they've asked a partner, they look around and see who else could they invite in the group. So while I say pairs, I mean threes if it means nobody stands there and feels left out for very long. And this was a class that we'd built that culture already, so it wasn't a problem for me to let them pick. If you don't know, this is called jinxwood, and these are matchsticks, and this is this reed, bamboo-y kind of reed stuff, and construction. Susan in the link put the link to Spectrum. This is where I've been able to buy all this, and actually I have a local guy who gives me the jinxwood, which is I think either balsa wood or basswood is what it's also called. It's easily cut by a handsaw, and with carpenter's glue or white glue and triangles, it can be joiced together. We build bridges, we build towers, we use matchsticks, we do swings. I can charge them a different amount of money for certain lengths of this wood, and I give them a design challenge, and then they have to figure out you know, how much it costs to build, and sometimes I build the scenario up where there's a kind of, it has to support a certain amount of weight, and you know, you get penalized for how much wood you use, and all these kinds of problem-solving challenges for students to work through. They love it, but that's not why I do it. That's a bonus. It addresses the curriculum. They have to measure. They have to problem solve. It's addressing the expectations. They're working together. They're communicating. They're using specific math language to communicate to their friends, because if they don't, the conversations take too long because they have to, you know, that thingamajig over there. So they're starting to talk about, you know, can you cut a 15-centimeter piece and butt it up at a 90-degree angle to this, you know, meter-long board. That's good communication. They draw sketches after they're done, which is the geometry of the different views of their construction. All kinds of challenges. I just make them up as I go, but if you look for STEM challenges, S-T-E-M, you could Google it and get 100 hits right away, or maybe even STEAM challenges, S-T-E-A-M. So the S is science, T is technology, engineering, and math, and then for STEAM, it adds the A for the arts. What I try and do is I try to think about when I use math outside of math class, and I try and bring those problems into class, because that's my goal. I want my students to be successful mathematicians as adults. I want them to be able to navigate the world mathematically. I want them to know how to calculate the tip at a restaurant. I want them to be able to figure out how much paint they need if they're going to repaint a bedroom. I want them to figure out their own flooring and things like that. So they're not taken advantage of, so they can buy the best deal at the grocery store. That's what I want for my students, so that's what I want my classroom to be like. Those are the problems that they need to solve. Stephanie asked a great question. Stephanie, what about both? What about if the students didn't know if they were in science or math and they were just learning? That's great, right? I'm a big fan of no subjects. Students just walk in, and when they walk in my room, they know they're going to be learning. It doesn't really matter what subject it is. They're going to be ready to take on any challenge that comes their way and just do some learning. And games. Games are a great way. They're naturally problem solving, especially the strategy games. Not necessarily all the commercial games. Monopoly, I'm not sure that's a great problem solving game, but there are definitely lots of math games. And I think if Susan's still here, she's going to put up a link to a collection that I have put together of games that I do in the classroom. This game here is called 3 to 15, and all it takes is 9 sticky notes. So I'll just kind of walk you through this game quickly. It's a lot of fun. And sorry, I just saw the link. It says intermediate math and it says upper grand. That's just an old wiki that I'm kind of just using the web address a lot for. So these games could be definitely, there's some primary games here too, so don't get thrown off by that. So this game, as I said, is called 3 to 15, and the premises of the game is you have one partner, or one opponent, I guess, I shouldn't call them partner, and the first person to hold 3 of these cards in their hand that total 15 wins. So it seems very simple, but once you start playing it with somebody, you'll realize it's quite a challenge. So I might take the 7 and my opponent takes the 1. I might then take the 8, which gives me 15, but I don't have 3 cards, so I haven't yet won. My opponent takes the 2, I take the 5. Now I have 3 cards in my hand, but the sum is 20. My opponent takes the 3, they have 3 cards, but their sum is 6. Now I have to put back 1 card and take another one. And this goes back and forth until somebody gets 15 in their hand. You can always see your opponent's cards, just like your opponent can always see your cards. I know it's hard to follow when it's just an explanation verbally, but this is a good game. Addition only, Kathy, is what we've played, but if you want to up the ante and add in extra operations, that would be something that people could decide. But so this is a simple game, simple in that it doesn't require a lot of teacher preparation. It's quick to play. It's great to fill 3 minutes. It's great to use for 15 minutes. It's great to build that math fluency, even just of addition facts, the making 10, the making 5, those strategies that help them with quick things. But look what happens. This is a game that my grade 7s made, and actually the grade 6s played last year too. So instead of 3 to 15, we called it 3 to 1.5. And now they have to make sense of how these numbers relate to each other and how will I possibly get to 1.5 and make sense of all this. This game we tended to play with partners, so 4 people. So my partner and I would be trying to get to 1.5, or a half and a whole is what we sometimes called it, before the partnership across from us. Lots of thinking here. Again, there's no clear path to a right answer. It's all about strategy. It's being reactive to what happens from your opponent. You have to make the decision, should I be aggressive or should I be defensive? All kinds of great thinking. And there are other games on that wiki as well. Assessment. Oh boy, here we go. We have 14 minutes left. Assessment. Here's where the rub is. We can't say that we're going to value one thing and then mark the wrong answer and always give them wrong answers. If we say we value process, then that's what we should be assessing. We have to make sure that we don't change the game on the students. So, gone are the days that we can just put great work on a page. And we know that gone are the days that we can write 7 out of 10 on the top of a sheet. All the evidence is that that kind of grading stops student learning immediately. As soon as they see a comment like great work or a number score, right from wrong or whatever, it stops their learning. Instead, and from Growing Success, we've been asked to focus our assessment on descriptive feedback, which these 3 statements would be examples of descriptive feedback we could be giving to students. I'll just give you a second to read while I swallow a mouthful of tea. That's a great point, Nancy. These comments help the parents so much. These comments should be from your success criteria that are posted in your classroom, or at least that students have access to some way. And these absolutely are your report card comments. These are all positive, so these all reflect strengths. For the next steps, I often phrase it like, would you consider including dimension lines next time so I could better understand your plans? That would be how I would word the weakness, or at least address the weakness by presenting a next step for the student. So if we're going to teach through problem solving, we have to welcome mistakes. We can't value them and punish a student for a mistake, so there's no punitive nature of making a mistake in a math class. We just give them descriptive feedback that moves them a little bit closer to greater success. And we need to assess frequently, but grade infrequently. There's a blog written by Stephen. Susan, do you know his last name? I wrote it down. I follow his blog. He's on Twitter a lot. Starts with a P. Stephen Prichnicki, I think it's pronounced. Okay, and Susan put the link to his blog here. But this is specifically his blog entry on grading and marking. And I liked it because it's very teacher-friendly, but he does pull in some of the research quotes about the negative effect of a grade and how we should really be only giving grades in elementary on the report card, and the rest of the time it's going to be descriptive feedback, which is the assessment. So making the distinction between assessing student work and grading student work. And just a reminder that the assessment should happen orally in a timely fashion. So that day, in that lesson, in that action period, in that 15 minutes of class, when the students were working on it, that's when they need the assessment. When they did the independent work that day, when they walk in the next day, your assessment is waiting for them with a, one of those comments or a would you consider for the next time. I used to use mailing labels. I would type, if it was the same, I would type the comment, because there are really only a couple things if you're focusing your assessment on your success criteria. There are only so many things you're going to be saying, because you can't talk about everything. You've got to focus on just your success criteria. So I would print them on mailing labels and then just stick them on the student work, so I wasn't rewriting by hand the same comments over and over and over. Absolutely. Our check brick, met, not met, for sure. If that's what works in your class, I think that's a strong assessment practice. We already talked about mindset, and because of time, I'm going to go over it quickly, and I think Susan's going to put up quite a few links about this. My caveat about mindset is please spend some time and actually read the work of Carol Dweck. I'm afraid it's kind of become a buzz, and people talk about growth and fixed mindset, and they don't really understand exactly what she talked about. So her research is quite rich, and it's a good read. So she's got some shortened versions if you Google her name, and some short summaries that she's written. But I think that it's worth the time to actually read her work, because it is getting quite watered down, and it's kind of becoming a buzz around the province. Oh, I'm getting a growth mindset. I'm telling the kids, you just don't know it yet, and that's great. I mean, that is what she said, but it'd be nice to work with the intentionality of what she was saying when we use that. And then Joe Bowler, who studied with Carol Dweck, and the forwards by Carol Dweck, and Joe Bowler's all over Ontario Math right now, and maybe some of you are lucky enough to be taking her courses through UCubed. Check out the resources from Joe Bowler, because she really talks about things that build this mathematical mindset. That mindset that a student comes in and they're okay to not know. They're okay with that cognitive dissonance. They're okay to persevere, and they're okay, and they know that when they do persevere, they'll get better at math. The right answer might not be tomorrow, but they will get better at their math reasoning with the perseverance. And here's just a sample of some of the resources that Joe puts out. And this is, she did kind of a two-pager of quick bookmarks and quick notes for teachers, and questioning that you could ask in a problem-solving situation that doesn't focus just on the right answer, gives you more to talk about than, well, that's right or that's wrong, because that's a pretty short conversation. But if you ask some of these questions, it's forcing students to really unpack their understanding and what they know, and when they articulate, they start to realize, oh, I do know this, I've got this, and I can talk about it. The other thing that I said I'd talk about is 21st century competencies. My hunch is that this is where our reporting will lead us. Because the kindergarten has left the subject areas and gone to the 4 frames, I'm kind of hopeful that our subject areas in elementary and the 1 to 8 will disappear, and we will comment on these 6 competencies soon. That's just a hunch. It's worth nothing, but that's just kind of what I'm hoping for when I kind of see what else is happening around the province. And Susan's already put a link to a great document just about how we need to teach in a different way. The experiences students have in our classrooms need to be different than the ones that we experienced, because the world is a different place. And when I looked at these 6 and I thought about that problem solving, even the one about the mosaics and figuring out that problem, there's critical thinking and problem solving. There was collaboration. They had to be creative in how they determined a solution, because I hadn't taught them any formulas. There was all kinds of communication. They started, if in the consolidation part I asked them to reflect, or maybe the independent practice would be kind of a reflective self-awareness question, that could easily be addressed. The only thing I don't see in most of my problem-solving lessons is global citizenship. And maybe I just need to, maybe there's a way that I just haven't thought about. So does anybody, if you come up with a good way to include global citizenship that's authentic, I mean, I could make it happen and force it on top, but I'm not a big fan of doing things like that. So I don't know how I would get to that piece. But I'm thinking if I hit 5 of the 6 competencies with every teaching through problem-solving experience, that I'm equipping my kids with the skills that they're going to need. So I have just spoken for almost 90 minutes straight. Do you have questions? Is there something that was discussed in the chat that I could comment on if you want to retype it? I skimmed quickly over assessment. I don't do a lot of grading. I will say that we are a Google board, so I have a Google Drive folder for all my students, and I have all of their interactive whiteboard files, and I have, if they're working on a spreadsheet and I'm making comments on the spreadsheet, I have that in my file. So I really just have portfolios of student work and student reflections. And then I kind of just, for assessment purposes, I really do rely on my professional judgment. As long as I feel confident that I've given students enough feedback, then I just assess them. And it's really broad assessment, because we're just on the levels, right? So anything in the B range is, they're okay. They get that grade level. Anything in the A's is, not only do they get the grade level, but they get it and extend it. Doesn't mean that if everybody else is doing 4 questions, the A students did 6. They did it in a way that wasn't expected, that was more sophisticated or brought something new to the table. It's not just working more or faster. C's are, they're doing some good things in the math that are related to the grade level expectations, but they're not quite there. And then a D is, okay, you know, we're really struggling here. We need to make another plan if they're going to go on and be successful in the next grade. That is really my assessment. Go-to for rich problem-solving questions. I do like the new Marion Small book. I don't know the title because it's not mine. I borrow and peer over my colleague's shoulder. To be honest, I make up a lot of questions just on the fly. I just see what's going on, the newspaper. So we did a lot of TFC stuff last week. We're doing a lot with Truth and Reconciliation. We're trying to figure out things there. Once you start to really teach through problem solving, you'll see so many math lessons that just fly across your face. We do a lot of our snack program work. We do the math for that. So we're looking at portions and rate and shopping and sharing. If I don't give marks, how do I prepare parents? I give them the feedback. So students, parents are aware of where their children are in relation to my expectations and to the grade expectations. If a parent asks for a mark, I can usually tell them, but it's fairly clear from the kinds of comments that students are getting. And I do believe it's important that we educate our parents that we're going to mark and assess differently. It's not okay to do the old practice, the way we got report cards and marks, and you know, every night a worksheet came home with a 8 out of 10, and if we got 8 out of 10 or higher, we got a sticker, and if we didn't, if we got 7, we were stickerless. And I don't believe that's appropriate anymore. So I would rather spend my time educating the parents as why that won't happen than doing it. Sorry, Susan, I didn't leave you enough time. I'm done.
No, you don't have to apologize. I can be very fast with my final. I'm just grabbing a couple of links here, and I'll put them in the chat. Before I do that, I want to thank you for another great session, Mary Kay. And I have to say that I am pretty sure I have not moderated a session where there has been such an active chat. I was showing many of you at the beginning how you can drag your chat box out to the side. I absolutely had to do that tonight so that it could be bigger and I could follow all the wonderful comments and questions and sharing all kinds of resources that you were sharing with one another. So thank you so much to all of you for that terrific involvement tonight. It was really wonderful. So I'm going to just take a minute here, and I probably should stop the recording, so let me do that. Thank you again, everyone. And Mary Kay, as was said in the chat, another great session full of wisdoms and great resources. So thank you, and have a good night, everyone.